Hello everyone. What I'm going to do today is something called definite integration. So we've been doing indefinite integration and we're now going to do some definite integration. Now, one of the things that integration measures is the area of curved spaces. So what we're really doing when we integrate a function, we are finding the area underneath the curve. Now, if you've got a graph that sort of looks like this, obviously the area under the curve between the x-axis and the curve goes on forever, right? That's indefinite, so you can't actually get an answer. But what if we put some limits on it? So why can't I change color? Oh, it's over here now. Oof, changed. So let's say that I want this particular area. So I'm saying, let's say that that's 2 and that's 5. I can find the area of this because it is limited. It is definite. It's not indefinite and goes on forever. So that's what I'm going to do today. So let's just get rid of this little thing. So first of all, we are going to integrate this. So I'll show you what we're doing in a second. Actually, first of all, let's just put in some numbers. Let's say that I want to find the integral of this and it's bound by 4 and 2. So my upper limit is 4 and my lower limit is 2. And I would like to know the area under the curved space on between this graph and the x-axis, right? Because we're differentiating with respect to x, so this we're talking about the x-axis between the values of 4 and 2. So let's ignore the 4 and 2 now. We're just going to integrate like we normally do. So I can say that this is, first of all, let's integrate this. So I get 3x add a power, divide by the new power, add a power, divide by the new power. All right, so that gives us, this cancels out to 1, so I've got x cubed, this becomes 2, so I've got 2x squared. All right, so now that I have this, I need to use these two numbers up the top. So I'm going to use the 4, and what I'm going to do is just exchange x for 4. So I'm going to say I want 4 cubed plus 2 times 4 squared. And then what I'm going to do is I'm going to subtract the other one. So I'm going to use 2 now. So I'm subtracting, oh, hang on. What I'm going to do first, I haven't written plus c, have I? That's a very important part, although it's actually not important in this one, and I'm going to show you why in a second. So we don't know what the plus c is. I should have put that over here as well, although we don't actually need to use it today, and I will prove to you why in a second. All right, so I'm now going to use the 2, so minus 2 cubed plus 4 times 2 squared plus c. All right, so now that I have this, I'm just going to solve these and do the subtraction. So let's go up here. All right, so obviously 4 cubed, so 4 squared is 16 to the times 4 is 64. So I got 64 plus, oh, this is another 64 plus c. Then I've got minus, I'm going to put some brackets in here still, 8 plus 4 times 4, which is 16 plus c. Now this minus, this is where you've got to be careful with your signs. If I just didn't write these brackets, I'd have the wrong signs because this negative needs to distribute to all of these. So let's write this out again. So I've now got 64 plus 64 is 128 plus c minus 8 plus 16, we've got 24, so it's minus 24 minus c. So see how the two c's are going to cancel each other out, like plus c and minus c? So, and that always happens, right? Because you're always adding a c here and then minus another c here. That's why we don't need to bother. When we're doing definite integration, you can ignore the c's because regardless of what they are, any number minus itself is just going to be 0. All right, so let's go back to our thing. So we've got 128 minus 24, so it's 104. So that means, if I zoom out, the area under the curve between 4 and 2 is 104 squared units. And that is how we use definite integration. All right, let's do another example. All right, let me start again. All right, so this time I'm going to integrate. Let's do something that's got some fractions. So let's say I'm going to integrate between 3 and 0, and I want 5x plus 1 and the square root of that with respect to x. So the first thing I'm going to do is rewrite this. So I want the integral between 3 and 0 of 5x plus 1 to the power of a half with respect to x. All right, so the first thing I'm going to do is do my integration. Okay, so let's think about what we need to do. We need to have 5x plus 1. We need to add 1 to the power. So we've got 3 over 2, and we need to divide by the new power, which is 3 over 2. Now we've also got a chain rule going on, don't we? So it's not just this, we also need to add in 5. So we need to do the reverse chain rule, put a 5 in here. So now we've got something a little bit messy on the bottom. So this is going to be 15 over 2. I am going to zoom out a little bit because I'm going to need a lot more room. I'm just going to move up a bit so we got more space. Okay, so let's rewrite this. So this is now 5x plus 1 all to the power of 3 halves divided by, this is 15 over 2. Now, instead of dividing by a fraction, remember we multiplied by the reciprocal. So actually, I'm going to say it's 2/15 all times this. So instead of dividing by 15 over 2, I times by 2 over 15. And I wrote 5 because I got distracted by too many 5s. Okay, that is a 3. All right, so now that I have my integration, I need to use the two numbers. So I need to substitute in my 3 and my 0. So I'm going to say that 2/15 times 5 times 3 plus 1 all to the power of 3 halves. And then I have to subtract the same thing. Why did I write 5 over? What? Why did I do that? Oh my goodness. 2 over 15, not 5 over 12. I'm going insane. 2 over 15 again. 5 times 0 this time, plus 1 all to the power of 3 halves. All right, so you can just type this straight into a calculator. You don't need to go through all the rigmarole of actually doing it by hand. If you type it into a calculator, you'll get 128 over 15 minus 2 over 15, which obviously gives us 126 over 15. Now, I'm quite certain that Josiah is going to use decimals because that's just who he is, but I'm going to say either of these answers is what I would prefer. Oh, this can be simplified. Obviously, you can divide both of those by 3, and then you can end up with 8 2/5, or what is that? 42 over 5. 42 over 5. So I would prefer either one of those answers. And that is how we use definite integration. So remember, all you're doing, let me zoom out again, all you're doing is integrating like normal. And then once you've done that, you just substitute in the biggest number for x first minus the lowest number for x second, and then you'll come up with the area under the curved space. So we have 8 2/5 units squared is going to be the area underneath that curved space. All right, good luck. Let me know if you've got any questions.